Geometry, Unit 5, Section 5, squares. So we've discussed every other parallelogram at this point. We discussed a trapezoid, which can be a parallelogram, but doesn't have to be. A trapezoid's got one pair of parallel sides at least. A parallelogram has exactly two pairs of parallel sides, so a parallelogram is a trapezoid, but it definitely has two pairs of opposite sides parallel. Then we had rectangle and rhombus, and the rectangle versus the rhombus was something that really needs to be remembered. Let me go back to this, that a rectangle has congruent diagonals and perpendicular sides, where a rhombus has perpendicular diagonals and congruent sides. So they're kind of opposites with respect to what's congruent and what's perpendicular. A rectangle has all angles congruent, a rhombus has all sides congruent. So they're very different, but when we put these two things together, we get a square. A square is a rectangle and a rhombus and a parallelogram and a trapezoid all in one. So it has all the properties of a parallelogram: opposite sides, parallel, congruent, opposite angles, diagonals bisect, all that good stuff. And it has all the properties of a rectangle: four congruent right angles, perpendicular sides form four congruent right angles. The diagonals are congruent. Diagonals are congruent, same length. And it has all the properties of a rhombus: four equal sides, four congruent sides. And the diagonals are perpendicular. So the diagonals are perpendicular and congruent, along with bisecting each other, but they all do that. And the sides are perpendicular and congruent. So we put a rectangle and rhombus together, we get a square. So square has every property we can basically think of. Um, so that's your square. All right, let's take a look at a proof. Now, again, in a proof here, there's so many different properties we could be using. If diagonals are drawn, then you could be doing diagonals bisect each other, diagonals are perpendicular, diagonals are congruent. The diagonals also bisect the angles. These are 45 and 45, because that's a rhombus property, and a square is a rhombus. So it could be diagonals bisect each other, they bisect the angles, they're perpendicular, they're congruent. It could be opposite sides congruent. It could be all sides congruent. It could be all angles congruent. There's so many different properties for a square. Let's take a look at a proof. All right, so ABCD is a square. I want to, and angle AFC congruent to AEC. Prove ABE and ADF. There are a lot of triangles in this picture. So I'm glad this is not a CPCTC one, because let's see, we got a triangle there, 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 and then we could kind of put a couple together. We got one there, and same thing on the other side. So I guess there's 4, 5, 6 triangles in this picture. We want triangle ABE, so this triangle here, congruent to ADF, this triangle here, ADF. So these two triangles. But this whole outside figure is a square. All right, so let's see. What are the many properties we could get from a square? Well, first we can say that this side is congruent to this side, because AD is congruent to AB, because all sides of a square are congruent. And we could also say that angle B and angle D are congruent. They're both right angles, but we could just say that they're congruent because all angles of a square are congruent. Now, these proofs are half done for you, and I'm doing the rest for you now. So your proofs usually aren't like this. You have to go start to finish. So you have to kind of look at them. Now, first thing I see, though, is, or one of the first things I see is I do have a diagonal AC, but I don't have the other diagonal BD. So that cuts out a lot of properties right there. I can forget about diagonals bisecting angles, diagonals perpendicular, diagonals congruent. Forget about all the diagonal properties if they don't have both diagonals drawn. I could definitely see some maybe alternate interior stuff happening with these transversals, but it actually doesn't work out here. Remember, always look for your triangles being a 180 rotation of each other when you're looking for alternate interior, and a translation of each other if you're looking for corresponding. And these really aren't either of those. These are like a reflection and a 180 rotation. So or I guess just a reflection across AC would do, but I could also think of it as a rotate 90 degrees and then reflect if I wanted to do a rigid motion here. But so the diagonal properties aren't going to be used here. Um, we got to think about the angles, we got sides, and that's really about it. You know, what properties of sides can you get as far as opposite and all sides congruent? What properties of the angles can you use? Anything about parallel, anything about diagonals? I mean, really those are the four things you got to kind of think about. Side properties, angle properties, parallel properties, and diagonal properties. We got something from sides and angles. Parallel is not going to happen here, and diagonals, BD is not drawn, so we don't have to worry about that. So that's one way to kind of approach it, is to think about those four things when you're given these shapes, whether it's a rectangle, a rhombus, a square, a parallelogram. You know, think about the side properties, the angle properties, the diagonal properties, you know, what's useful. And always keep in mind of our ultimate goal, trying to prove what we're trying to prove. The next given was AFC and AEC. So AFC is here and AEC is here. These are exterior angles to the triangles I'm attempting to prove. And so whenever that happens, our supplementary process happens. And so I can say that AFC plus AFD is this angle here. AFC plus AFD equals 180, and AEC, AEB, this angle here, they add to 180 because two angles that form a linear pair are supplementary. And remember, supplementary, whenever you're given exterior, same thing's going to happen. And supplementary is a two-step process. Like perpendicular is a two-step process. You got to first declare right angles, then congruent. Well, we first have to declare supplementary relationships happening, and then we can say congruent. And the reason here is supplements of congruent angles are congruent. Do not say supplementary angles are congruent. That is not necessarily true, unless they're both 90. But supplements of congruent angles are congruent. That is definitely a true statement. So that got us that. We had the angle here from all angles congruent. We have a side here. So this is an angle, angle, side proof. Congruent to angle, angle, side. All right, so that's it for the square, and that's it for our parallelograms in general. We're going to see these again when we get to a coordinate chapter a few months from now. We're going to prove these through, given 4 points, prove it's a square, prove it's a rectangle, prove it's a rhombus. So these parallelograms, they come back with their properties in a big way when we get to coordinates, and that's a pretty heavy algebra chapter with distance and midpoint and slope and different things like that. But for now, it's just using these properties and proofs and a couple little solve for x type of things. But that's it. Remembering the properties of a square is not bad because it has basically everything. I think really the most important thing to remember is the rectangle versus rhombus properties, because we confuse those quite often. And just be careful with your proofs and use all the givens you have and the methods you know how to do them. So see ya.